Lesson 7.10, implicit differentiation at a point level 2. These really aren't any harder. They're just level 2 because they're not giving us an actual point. They're just going to give us one of the values of the ordered pair, and we have to then plug that in and find the point. They're also wanting us to write an equation of the tangent line, and it could be more than one. So these first two, I'm already telling you there's one. You'll know right away when you plug in the value if you're going to get one answer to it or two. So let's go ahead and try it. So step one, if you want to write that down, you can. But I'm going to take my original function. I'm going to plug in x is 1. That'll get me my y value when x is 1. So I have negative and then my 1 squared times y equals negative 3 times 1 cubed minus 2y. 1 squared is 1, but times a negative makes it negative 1. Y. 1 cubed is 1 times negative 3 is negative 3 minus 2y. I'm going to add my 2y over. So 2 minus 1 would be 1y, or y equals negative 3. That tells me I'm really trying to find the tangent line when x is 1 and y is negative 3. It's the ordered pair. And you will not have the graph on Delta Math until you've already answered the problem. I just put it there to hopefully help you understand what we're trying to do. Step number 2 is to find change in y with respect to change in x, or with respect to x, or otherwise slope. So I'm going to write the function again. Put brackets around the whole thing. Take this times d over dx. Okay, I've got a product rule here. So I'm going to take the derivative of the first part. That would be negative 2x times just a normal y plus, now I'm going to keep the negative x squared, but then take the derivative of y, which I'm going to call y prime, equals negative 9x squared. That would be negative 2, but I have to have times y prime. Okay, so you don't have to do this on the first one. I think I will. The second one I may not. But I'm going to go ahead and do what I've been doing and get y prime by itself. So I have to move it to the other side. So I'm going to add 2y prime over, making it positive. I'm going to add 2xy over, making it positive. Okay. Hopefully you're getting good at seeing that what's going to factor out gets divided here. So I can go ahead and say y prime is going to equal 2xy minus 9x squared over, this would have a 2 left, minus x squared. Okay, so now what I want to do is plug in my ordered pair, 1 being my x, negative 3 being my y. So I would have 2 times 1 times negative 3 minus 9 times 1 squared all over 2 minus 1 squared. That would be negative 6 minus 1 squared is 1 times negative 9. 1 squared, 2 minus 1, 1. So I get negative 15 over 1. This is my slope. So to write the equation of the tangent line, it goes y minus my y1, so it'll be plus 3 equals my slope of negative 15 times x minus x1, or 1. And then here's the graph. So at the point, or when x was 1, we found out that y is negative 3. And then the tangent line, look how steep this slope is. It looks like it's going down 15, right 1. Down 15, right 1. So that looks good. All right, next one should say number 2. This time they give us y equals 1. So first step is to plug y in. So I'll have negative x times 1 squared plus 1 to the 4th equals negative 1. Easy enough. 1 squared is 1, so that'd be negative x plus 1 equals negative 1. Subtract 1. Divide by negative 1. So x is really positive 2. So my ordered pair is 2 comma 1. Now all I have to do is find the slope. So I'm going to write my function again. Take it times d over dx. Got a product rule again, so derivative of negative x would be a negative 1 y squared plus, keep the negative x, and then that would be 2y y prime plus 4y to the third y prime equals 0. So what I was saying you have a choice of is, since I have an x and a y, I could plug it all in now and get y prime, or do my isolating y prime and have just an easier function. It's totally up to you. I think just to have something different, I'm going to plug it in right now. So I've got -1 times my y value is 1, plus a negative of my x, so that'd be a -2, times y is 1, y prime, plus 4 times 1 cubed, y prime equals 0. 1 squared is 1, times -1 is -1. -2 times 1 would be -2 y prime. Oh, I forgot the 2. Sorry. So that is a -2 times 2 times 1. So that would actually be -4. Y prime, and then 1 cubed 1 times 4 is +4. Y prime equals 0. Slight issue here. I see that -4 y prime plus 4 y prime is going to cancel out. They're like terms, I put them together, they cancel. When you learn this back in algebra, this was a special equation that either had infinite solutions or no solution. Well, in this case, I've got a -1 on the left equaling 0. That never happens. When I get this in an equation, this means that I have undefined slope. If you would have isolated y prime, I don't know what number on top you would have had, but when you plug in, you'd get a number over 0. We know when we're talking about slope and we have a number divided by 0, that also means it has undefined slope. So either way you do, it's fine. You're going to know that you have undefined slope. But what does that mean to us in terms of how do I write an equation of a tangent line? Undefined slope means it's a vertical line. And when I have a vertical line, it cuts through the x-axis. It has to start with x equals something. So all I have to do is look at my ordered pair and pick out the x value. So x equals 2 is all I would need to write. And you can see here in this really weird graph that when y is 1, so when I have a y value or height of 1, that would be this point right here at x equals 2. Where does it have, or what makes it have an undefined slope would be the vertical line here, which is x equals 2. So that makes sense. Okay, and then there's one more I want to do. Oh, I didn't change the number of any of these. I should say number 3. I want to show you what happens when you get 2 tangent lines. So go ahead and plug in that y is -1, see what you get out for x.